Hello there, Mr. Sutton here, bringing you the IM3 Chapter 7 Quiz 2 Extra Practice Solutions on right triangle trigonometry. For this problem, I'm trying to find a missing angle in a right triangle, so for that I can use SOHCAHTOA. Now it looks like I've got the hypotenuse side here and also this side that's not the hypotenuse but it's touching the angle, it's part of the angle, that's the adjacent side. So we've got adjacent hypotenuse, that's the ka part of SOHCAHTOA. So that means we're using cosine, and cosine is going to be adjacent over hypotenuse. So for my cosine, my angle here, I don't know the angle, so I'm going to call that x. That's what I'm actually solving for. The adjacent side, that's this non-hypotenuse touching side here, that's 12. And the hypotenuse is 14, that's always across from the right angle. To actually get x, I'm going to need to do an inverse trig function, cos inverse of 12 over 14. And let me use the calculator to see what that is. So on the calculator, let me go to second cosine, and we'll do 12 over 14. And my calculator is hopefully in degrees mode for this. So that's going to come out to 31.0, and that's degrees. On this problem, I'm trying to figure out this missing side in a right triangle. Since this is not a 30, 60, 90 or a 45, 45, 90 triangle, and since I don't already have two sides, I'm going to have to use SOHCAHTOA for this one. In terms of the sides that I do have involved in this problem, I've got the opposite side here across from the angle, this 58, and x is the hypotenuse side. So if I have opposite and hypotenuse, that's the SO part of SOHCAHTOA, which means that sine is my trig function for this one. So I can write sine of theta equals opposite over hypotenuse, and then we're having sine of the angle here, so sine of 95, or 25 rather, 25 degrees, equals opposite, so that's 58, over the hypotenuse of x, and now I have to solve for x. So the quickest way of doing that, if I multiply both sides by x and then immediately divide by sine of 25, basically switching the x and the sine of 25, I get this rewriting of the equation. And now I can just plug this into my calculator to figure out x. So on the calculator, let me do 58 divided by, and let me do sine of 25, and maybe close the parentheses there, equals, that's 137.2 if we round that off. To find the missing side of this right triangle, since we've got one other side and an angle that's not 30, 45, or 60, we're going to have to use SOHCAHTOA. So looking at the sides that are involved, we are looking for the side across from the angle, that's the opposite side. We have the non-hypotenuse leg of the angle, the side touching the angle, that's the adjacent side. Adjacent and opposite, or opposite and adjacent, either way you look at it, that's TOA from SOHCAHTOA. So that means we have to use tangent equals opposite over adjacent. So we can write tan of 72 degrees equals my opposite side of x divided by my adjacent side of 18. And let's go ahead and solve for x now. So to do that, I just multiply by 18. So I have 18 times tan of 72. And now I'll just plug that in the calculator. So on the calculator, making sure we are in degrees mode, this is going to come out to 55.4 if I round off to the nearest tenth. For this problem, we're trying to solve for this missing angle. Since I have two sides of a right triangle, I can use SOHCAHTOA to work backwards and get that angle. The sides that I have are the hypotenuse, that's an easy one to pick out, across from the right angle. And this other side here that's across from the angle, that is the opposite side. So opposite hypotenuse, that's the SO part of SOHCAHTOA. So that means we have sine equals opposite over hypotenuse. So I can write sine of, well, let me just give this variable a name. I'll call it x. And then we have our opposite side of 24 divided by the hypotenuse here of 26. And now to actually get x, I have to take the inverse sine of both sides here. So I've got sine inverse of 24 over 26, which I will now plug into the calculator. So to get this, I just did second and then sine. In general, second, whatever trig function you need the inverse of. Notice that little -1 there. And now if I press enter, I get 67.4 if I round that off, and that is in degrees because this is an angle. For this one, we have a word problem.
A wire attached to the top of a pole reaches a stake in the ground 35 feet from the foot of the pole and makes an angle of 41 degrees with the ground. We want the length of the wire. So just to draw out this situation, we've got a right triangle going on. The pole is the height of that triangle. Since we're talking about the angle that the wire makes with the ground, this is going to be a right side up triangle, like so. And we're just going to label the different parts of this and solve for what we're missing. So let's see here. We have a stake in the ground that's 35 feet from the foot of the pole. So here's the pole over here on the right. The hypotenuse is the wire leading up to that. And the stake in the ground is here in the lower left. Feel free to draw this stuff in. So we have a distance of 35 feet between the stake and the pole. And now we said that we have an angle of 41 degrees with the ground. That's the angle between the horizontal and the hypotenuse here, 41 degrees. And we could call this an angle of elevation if we wanted. And we want the length of the wire. Remember, the wire is this hypotenuse being stretched between the stake and the top of the pole. So we're going to call this hypotenuse x. So now we just have to solve for x using SOHCAHTOA. So x is the hypotenuse. This 35 here is the non-hypotenuse leg, the adjacent side, based off of this angle. So adjacent hypotenuse, that's going to be cosine. Cosine equals adjacent over hypotenuse. So we can write cosine of our angle, 41 degrees, equals my adjacent side of 35, divided by my hypotenuse of x. And now I'm solving for x. To do that, I have to multiply x by both sides and then divide by cosine of 41. So basically switch these two things to get x equals 35 over cosine of 41. And at this point, there's nothing else for it. I've got to use the calculator. So on my calculator, I've got 35 divided by cosine of 41. Press enter. And that is 46.4. 46.4 what? Well, we have distance units of feet, so that's going to be in feet because that is a distance. For this problem, we have a lighthouse built at sea level that's 210 feet high and a boat 300 feet away from the base of the lighthouse. We want the angle of depression from the top of the lighthouse down to the boat. So since we're talking angle of depression, we have an upside down right triangle. So here's the lighthouse top in the upper left. The boat is down here in the lower right. They said the lighthouse was 210 feet tall. Well, the lighthouse is over here, but the height of the lighthouse is actually represented by the right side of this triangle. So we'll put 210 here. And then the boat is 300 feet away from the base of the lighthouse. Well, here's the base of the lighthouse. Here's the boat. So this distance down here is 300. But again, it's not part of the triangle, so we will use the top of the triangle to represent that 300 feet. And they want the angle of depression. So that's going to be the angle between the horizontal and the hypotenuse side of the triangle. So this angle right in here. And to get that, we're just going to use a little SOHCAHTOA. So the height of the lighthouse, that's actually the opposite side across from this angle. And then this 300, that's the adjacent side, the side that's touching the angle but isn't already the hypotenuse. So opposite and adjacent, that's TOA. So tangent equals opposite over adjacent. So we can say tan of x equals my opposite side of 210 divided by the adjacent side of 300. And to actually get x, I have to do inverse tan of 210 over 300. Let me use the calculator for this. So on my calculator, I just did second tangent to get tan inverse, 210 over 300, and that's going to give us 34.99. So if I round it off to the nearest tenth, that's actually 35.0, and that is going to be in degrees.